What's up, guys? Hope you're doing well. Uh, so in this video, I'm going to be showing you how you can make snake in C++ with using SDL3. Well, I don't know about showing you how you can make snake. I guess I should frame it as I'm gonna be making snake in SDL3 using C++. I'm gonna go over like some bits and pieces. I'm gonna talk while I'm coding because like one of the things to that is kind of like fucking annoying, also fun. It's like making like the entry stuff. The reason why I say it's annoying but also fun is because oh my god, I'm doing hello world. Oh my god, I'm a hello world. If that makes sense. So I like to make my functions and like a function that I wanna like get an error checking on inside of like an if statement. That way I can initialize it and also get the error at the same line. And you're gonna see that be a pattern for me when I like do things like initializing SDL video. Video so in its events, but I'm also gonna put events because why not? And if it's false, it returns a 0. You can also just do this if you want to make it look like, you know, cool or hacky to somebody to know what the fuck programming is. Shit, I'm losing my train of thought. Okay, I should I'm like talking like so weird thing. Okay. So I'm gonna be making snake in SDL2. Felt like making it. I wanted to make it before, but in its error. But personal stuff just got in my way. So I'm gonna initialize SDL3. Oh, and this is the steps we're gonna do, by the way. I said it to just like write it and then start the video because then less time is wasted on me typing this. I'm gonna make a window, draw a grid, draw a square, collision logic, draw the snake, and I guess 6 would be snake logic. I think that will make sense. We're gonna even add a score too. Score system, bonus score system. We can even add cheats or like cheat codes. Cheat codes. You can add cheat codes. I don't know if you want to see that. I don't know if it'll depend. If it's too long, we'll see. Because I already said it. It's like, you know, maybe I have to like show it. You know? If you're familiar with my previous SDL videos, I like to make a struct. I like naming it SDL app type. You can also make this be a class, but then you have to do something like public, and it's just like and let's just make it a struct, right? SDL app type. And I like to make it so my render SDL window. I like putting in no because SDL is a C library, so I put no because I think it would. I mean, you can even see it has like a colon no. If I do no pointer, it'll do the same thing. Oh my god, it's not showing it. It's annoying. Oh god, it's not showing it. I'm embarrassing myself. Oh no, char pointer A. Please show it. Oh my god, okay, it's not showing it. But a no pointer becomes the same thing. So you can also use no pointer, but I'm gonna put no because I'm nitpicking the fuck out of this. I'll be honest, alright? I'm nitpicking it because it's like the best thing about C++ is that you can wrap a C library in like C++ type names or not type names, templates or vectors or like whatever you can do in C++. And Let's make this be false by default. And with no, I like to use no pointer, but I heard that with no, it's better to use no when working with like the C library stuff specific. Even though, let's be honest, the compiler will handle that for you. The developer of the library, he's a fucking god. He already knows what like to handle things with people use no pointer for it. But I'm just gonna like I'm just gonna put no to like look smart. I'm joking. I'm gonna put no because it just seems to make more logical sense when like working with C stuff. Whenever I'm doing like stuff that is not even like related to C, I'm just gonna put no pointer. Yeah, I'm a fan of Terry Davis, and one of the quotes that I really like from him. It's an idiot admires complexity, a genius admires simplicity. I love that quote. I love it so much. I even use it outside of technical stuff because it's just so fucking true. It's like hold on, window height. Okay, I think that's good. It's like you have these fucking people that like to make shit so complicated, so perplexed, do all this weird shit like how I'm doing instead of using no pointer because no pointer C++, and I'm using like no and like no pointer. Who just like to complicate something. It's just like, dude, just fucking do it this way. Like, what are you doing? I think I can do this. If no pointer equals, what the fuck? That's what it recommends me to do. But then also recommend. Oh, okay, it's just like the specific ways it. This is really fucking cool that I can do that. I'm gonna leave it though. How I had it. Yeah, like that. Yeah, man. What the fuck did it do again? Whoa. I'm like burning through, burning through fucking time. God damn it. Just like wasting. Okay. I need to get this. I don't know why I'm so jiggly. Not jiggly. Giggly. It's just. But yeah, we'll make the like some shit be so fucking complicated. Window. So fucking complicated. And that's what I kind of do right now. But you know what? Fuck it. I just gotta roll with it. Like I kind of like it. I like you doing things like this. The reason why it's like a mental disorder. Okay, it's like that. It's like I see this shit and I'm like, oh my god, it's a thing. It's a C library. I'm wrapping it in C++. I know I have to put it as no pointer. It doesn't matter, but it's a C library. It's like I mean, if you think about it, if you really think about it, like this is like the way you should do a thing. It should be this way, right? No pointer. This is like it's like with a C library. If it's like you want to like specify something, but at the end of the day, it really doesn't fucking matter. Is this not right shit? If app render equals SDL create render. Oh, whoopsie daisies. But yeah, you can see me use no here. With create render. Okay, maybe. Maybe it doesn't say it here. Okay, it says it right there. Parent name, right here. Parent name. Let me just wiggle it. Oh my fucking god. Parent name, the name of the render driver to initialize, or no to let STL choose one. We're gonna let STL choose the rendering driver. I think you can get it by doing like some not hacky. I think they have on the wiki. How you can get like every driver name, then you like pass it here. But I'm not gonna get it like to be so fucking complicated. It's snek, all right. You don't need to do like a million bajillion things. Just let STL choose one. Unless you probably have like some I don't know, like okay, like if you really want to use it, you can like Google it. Like we got the internet. So we're gonna exit out of the render function. I know in like a previous video I said that I don't really care that if the render is bad. I only care if there's no window. I'm not, since I'm like showing like a video, I'm just gonna like do it this way. Because at the end of the day, I mean, it's the same shit. Like if you don't got a render, I'm just gonna close the application. It's just like, you know, it's like just destroy this. So I'm gonna like free everything. You don't have to do this by the way, but I like making it so the operating system doesn't have to free the memory for me. I like me myself freeing the memory. Let's see. So at the end, I like to destroy the render first. You can probably see what I'm trying to do here. I mean, it's very specific. Like if you touch SDL3, and I recommend you like do like some basic SDL3, or at least first learn how to program. So when I started programming, I started in C++, by the way. It was like a whole turmoil. And no, I didn't like start with C++. And I started with C++. I moved to Python with Pygame. Actually, let me. So I started with C++ and with SFML. I knew nothing about C++. I was like reading this book, and I was just lost. That book had like a mix match of C and C++, and I was just so lost on what the fuck I was doing, and I just kept copying from the book, and that was bad for me to do at the time. You need to learn to code and program in the language you're programming in, or at least understand the basic fundamentals of programming. Like if you're able to take code from another language and implement it in like this language, like Java code, implement it to like a Java application, and you can like make it work, make like a similar work of it, but in C++. You need to like have that knowledge to like get started doing like things like these. And because when I did that, when I was like programming without any programming knowledge, except then wait, I was lost and I just kept copying things. I want you guys to know, I like to run my cases like this with like scope, with the bracket scope. I think it's organized that way. If you guys don't know, the fuck was I saying? I'm saying like a million shit. It took me like 1 year for me to learn how a for loop works. I was terrible, fucking terrible at fucking programming. There should be no reason why it takes someone 1 year to understand how a Actually, I'm gonna make a goal pointer key state. So this is gonna be our keyboard input. SDL, yeah, keyboard state, and it's gonna be no. And then what we're going to do is if key state SDL gets scan code. Wait, what am I saying? SDL scan code escape. So if we press the escape key, we also want to close it. So we make it into false. That we can like run this and then clear from application successfully. Okay, I want to like explain this first before I like talk about like my fucking story. So with this, with set render draw color, you can see it's asking us for like, look at that shit, RGBA 1 2 3 4 fucking parameters. I know SDL has SDL color, let's just name it that, and you can like do color R, color G, like, but I don't want to do that shit. It sounds like such a fucking pain to like apply that to each set render draw color. So what I do is, I got the sniffles. I make a macro called colors. Color. I'm gonna name it color. Fuck! I'm gonna have to use the bathroom. Okay. Hold on. I gotta use the bathroom. I'll be back. All right. So I'm back. The fuck? Oh, right. So we're gonna make color. So let me explain this. I explained this in I made like a video explaining colors. I think I had some errors in that one. I can't remember. So I'm gonna explain this. Okay. So color is gonna be a UNC32. That means an unsigned integer. It's gonna be an unsigned int. I'm gonna just say that way it's easier to comprehend. And an unsigned int has 32 bits. 32 bits is RGBA. It's basically this, which is 4 bytes. 4 times 8, 32. So what we're taking is we're taking like this value and we're putting it here. And this value in here is here. Will get shifted to the right 24 times. I should let me do this. That way it's easier for you to understand. So this is gonna make green and blue mixed together. Well, what color that made? Green, blue. I was gonna say teal, but I'm not sure. So we move it to 24 times to the right. It's gonna be 0x00 000000. And then what we're going to do is we're gonna mask it with 0x0f. So we mask it with 0f, which is 255. And if you don't know, 255 is the maximum value of an unsigned byte, which is 8 bits, which is an unsigned char. That's what a byte is. An unsigned byte is an unsigned char. So if we mask it with this value, it's gonna give us this, the last two bits, the last bits of the last bit value of the thing, which is going to be 0x00. If we have ff here, it's gonna be ff to the last, and then if we mask it, it's gonna give us 0xff. This is basically gonna make us just ignore everything here, and we just want this value. That's what we're telling it. So that's why we move it like 24, so we can put like the first value to the end. And then we're going to have color 16, because then we want to get the second byte. So the G, which is going to be green. And we also going to bit mask it, which is going to be FF. FF is alpha, but I can just make it be 0. That way it's more to comprehend. And we shift the 16 times to the right. And this is hexadecimals, which I think there's 16 bits each. I might be wrong. Okay, I haven't been coding in a while. My mind is like fucking like I forgot this knowledge. I just have like instincts, if that makes sense. And this is gonna take these back. So moving it once will be 8. Moving it twice will be 16, which is gonna be 000 ff. Then we mask it, and we get this value. All right, that's all it is. The same with this one. So 8, mask it, and then for the last one, well, the last already has the final value, right? We're already at the last well, I say last, but it will be like the first. We're already like the first bits, first bit. So we just mask it. So that in parentheses. So we just mask it to make sure it gets the last value, and that's it. That's all it is. If you're in C, actually I'm gonna do it first. So I like to use enums because we're in C++, of course. Class enum class. All right. Scope scope enums. All right, not that C global enum bullshit. No, here we're dealing with scope enums. Enum class, I'm gonna name it colors, and I'm gonna name it color. Let's see, color black. So R, G, B, and the A, which is alpha, which is basically the opacity of the color. Sorry, my voice is. Let me drink some water. My voice getting raspy. Talking so much. Talking so much shit. Talking so much shit. So we got color black. So R is red, obviously. G, green. B, blue. And then A is alpha, which is gonna be max of opacity. Alpha is opacity. And you can see we get no errors here. There's a problem though. Watch what happens when I do color red. 0xFF 0000 FF, which is RGBA. So A is FF, R is FF, because we want the opacity to be the maximum and the red to be maximum. And every other color, green and blue, to just be 0. You see though, it gives us an error. Why is it an error? Well, it says it right here. Enumerator value evaluates to 4 million blah 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 blah, which is gonna be cut now to type to an int. Int, that's odd. Why is it an int? Well, by default, enum classes handles integer types by default. We got a you can even see it right there. It shows it. It shows like enum class colon int. We gotta specify to our enum class that, hey, we want you to handle unsigned integers, unsigned int. So now our enum is handling unsigned int, so the value is big enough to handle 4 bytes now, 4 unsigned bytes. That's what we're doing. You can also do UN32. I like using UN32. UN32 is also like a type definition to the SDL SDL has. So I'm gonna use that because I'm using SDL. But you can also use unsigned ints. I'm gonna specify int32 though because I think that's just more precise. It's the fucking shit that I was talking about right here. It's like the no. God damn it! See, it's like a fucking mental illness. It's like I'm something fucking crazy right now. But yeah, we're just gonna do all the rest of the colors now. So we got green, blue, and then we're gonna do white for last. 0FF. White is just max value everything. Black is minimal value everything. I mean, you can even make this be 0. And by the way, the reason why black wasn't producing any errors is because the value of black in hexadecimal when we make all this 0 and this FF is 255. So 255 can fit in an integer, but this value, since we have the topmost left be FF, then we're basically saying the highest value of an unsigned integer. Fuck, I'm probably saying this shit fucking wrong. So this is probably like 4 million something with like 255 added to it, which is way bigger than an integer can handle. I think an integer can handle. An integer handles half of an unsigned integer because an integer has to handle signed values, which is the negative values. An unsigned integer doesn't deal with negative values. It goes from 0 to like whatever maximum value it is. An unsigned value goes from 0 and also -1 to whatever negative value maximum I can go with. I'm just gonna fucking say I like talking shit. So a char is a signed value, which is basically your signed char. That's what a char is. So char goes from -128 to 127. Meanwhile, an unsigned char goes from 0 to 255. So these values R to size 0xff is 255, we cannot use assign char. And this is the same case with integers. We cannot use an unsigned integer here because an integer cannot hold these values. You can only hold this one because this is just 255. I hope that makes sense. So then we got our enum colors, and what we can do is we can do colors scope colon, and we can pick let's make it be black. And you can see we have an error here. The matching function call. Oh, it's because I need to have the thing. So we have to put the color inside of our macro, and then we do colors black, and our macro spans to this. You can see it. Like, look at that. Handles all that for us. This is how you should program. Program smartly. Automate shit. Alright, when you program, make it be easier. Don't make it be harder and fucking complicated. Make it be easier and understandable. Don't code like pirate software. Oh my god, okay, I'm just fucking around. But you can see we're still getting an error. Invalid operands to binary expression colors and int. Well, so color things we're handling integers, and not only that, colors is a data type of enum class. What we gotta do is we gotta cast it to be a UN32, and I think behind the scenes the compiler like handles everything for us once we apply this conversion. So now what it does is it gets the value of color black, then it converts it to a UN32, and colors like, okay, it's everything's a UN. You can't even see it. Look at this shit. You think I'm gonna type what this shit by fucking hand? Hell the fuck no. What the fuck? Then we got our colors. We can render render clear, and it should clear the render with the color we specified. Then we want to present. Let's get this shit up here. This render present app render. So now if we compile it, so I'm going to do compile command, which is like an Emacs thing. If you have an IDE, you just like click the little run button. You can see you can even do on the terminal if you select something like Vim. I use Emacs because I'm not gonna say it, but you know what I am gonna say, because Emacs is just better than Vim. Okay. So we can do GCC. Well, it will be G++. You can use GCC or Clang. I'm gonna use Clang. And I'm gonna like, if you're on Windows, I'm sorry, but just make sure you got like everything set up to run SDL3, and then like everything should just work for you. You can just like press the little play button, and then Windows will like take care of everything. But if you're on Linux, these are the compiler commands that I'm going to use. Also going to use pedantic. So pedantic errors, which is gonna make us make sure our code is standard to the ANSI C++ standard, I think. And if it isn't, it's gonna give us errors. So the library, our flags, and I'm also going to pass I was gonna say main snake cc. I name it snakes.cc, but you can name it snake.cpp or snake.cxx. I just gotta name it cc. So I'll put snake and area. Now I'm gonna add another command, separate it from this. So once this finishes, it does this command, and it's gonna be snake. Boom! Look at that, we got our window. Yeah, and yes, I'm using Wayland. Okay. Now that we have that, we need to make our grid, which is step 2. So I'm gonna make a function called draw grid, and we're gonna have SDL render. It's the first parameter, and color as the second. Notice I don't pass a pointer or a reference here. The reason why is because I'm going to pass in the parameter. I forgot the name of this, but it's like I'm not gonna create a variable. All I'm gonna do is just like declare the value inside the parameter. So I'm gonna do something like color black instead of like the parameter. So it doesn't even need a copy by then. I hope that makes sense. I'm terribly sorry. I'm just terrible at fucking explaining things. We also want to pass in the color. See, you don't have to worry about none of like passing RGBA or that stupid shit. You just do this. Boom. Easily does it for you. Smartest way to program. I'm gonna make an FRECT. If you're in SDL2, so in SDL3 they focus more on making FRECTs. Well, in SDL2 I think they use integer recs. I prefer FRECT because it's just more precise. But you can use integer recs. So we got FRECT, and this is gonna be our column line. I made a video on how you make a grid in SDL3, and it like goes over detail on what I'm doing here. But in short, I'm just making like a line that starts in our origin, and then we're gonna increment the line by a certain amount, and then it's just gonna do something like this, which is gonna be our column line. So we're gonna make a for loop, column line that y. We're gonna make sure that when we call the for loop for the first time, y is set to 0, and we're gonna make column line y. If it's less than the window height, we're gonna increment the y position, because remember, incrementing it is going down, decrementing is going up. The column y by. So how big do we want each gap to be from the line? I like to name that be the square size, because it detects what the square size is for your. I was gonna make a macro. I had like fucking zebra in there. I'm using constant expression because it's compile time, and also with constant expression you can get you're able to get like warnings and errors with it. Well, with a macro, like I do define window width, right, something like this, and a name it like 480. I think it's the same shit, but except it doesn't like it'll be hard to like detect errors. So I have square size, and I'm gonna make it 24. You can make this be a UN32, an unsigned integer, because there's no reason why we should have this as negative. But I'm just gonna make it an int. Because why not? Because why not? And we're gonna increment it by square size. Also call it line gap, whatever you want. I think square size just makes more sense. Sorry about that, I was clearing my throat. So then we render it, render rect. So in SDL2, render rect would take integer rects. In this one, see, it takes f rects, which is why I said the that SDL3 seems to focus more on using f rect than integer rects. And that's it. Then we go down here, we go here, and we put draw grid. Our draw grid function, we're calling it. We pass in that render, and then that color is gonna be colors. Let's make it be white. So see, this is what we do. It basically just pass in like 0x f. That's all it's doing. Which is cool. But then we can run it again. And it's giving us an error. Designated initializers are a C++ 20 extension. You son of a bitch. Okay. So what this means is we have to do this the lame way and do it the way C does it, which is like this, which is not as efficient, but that's okay. What? I'm sorry, what? This. Let's do this. And boom, look, boom. Wow, amazing. It works really well. So yeah, I guess we kind of like specify. I mean, it just seems kind of stupid. Like, isn't it the same shit? Oh wow. But yeah, it works. You can see our line. So now let's make the a row line, which is gonna go on the bottom, and it's gonna like go by SDL3 row line. So it's the same shit. We window. So this is gonna be 0, and then the height is gonna be the height. That's when we wanna go all the way to the bottom, and then we're gonna like go by the X position. So yeah, about my story before, I didn't know that I didn't know how for loops work for like a year, and the reason why is because when I started programming, I started wanting to like immediately like build like a fucking big ass game, 3D, fucking. I'm gonna make Dark Souls 3 in like 2 days mentality. Actually no, that's not true. I started with like a mentality of I want to like do something cool, and I had like a book that teach you C++ by like building like a game, and I thought that was really that was really a badass. But the problem with that is that if you don't know the basics, you won't understand the rest of the things like enums and stuff. And I didn't even know what an integer was. An integer, an unsigned integer, like what's the difference? A void. What is a void? You mean like the abyss? like the void abyss like in space? I didn't know what the fuck that was. And when I started like I was just copying down, not even knowing what was even happening. And I had like some idea of it, right? But I really didn't know, and when I got to like a chapter in this book where I was like building like a zombie arena, I was like, man, I encountered like one bug, and I didn't know what to do. I was like a lost puppy, and I was like, well, I don't know what to do. If I change this, what does this even do? And that's when I realized, man, I'm not learning anything. And I was like stuck in this loop of I need to find like a course. And the course I found was just my next language was basically Python Pygame. And you know what that was? It was just instead of SFML, Simple Fast Media Library. That's what it is. It's like a C++ version of like for graphics programming. What I did instead was switch to Pygame, and I did the exact same shit there. So now I'm in a new language. In Python, at least it's more understandable, right? Because it's like it follows the English syntax more. It's more high level. And I was like stuck. There you go, we got the grid, but you can see it's a little bit off. And I was stuck. The reason why is because it's because of math. If we do something like 640 divided by see our square size 24, we get like a floating number, and that's what we get. That's why we have like a weird gap here. If we do something like calculator, if we do something like 640 divided by 48, whoops, sorry, 24, like 648 divided by 24. You can see we get 27, so that means 648 will give us a whole number, which should fill the C. You can see it fills the graph. So I kept like repeating this mistake, and I didn't even know the basic. And then you know what I did next? Oh my god! Then I was confusing Pygame with Python, and I went to Godot, the game engine. And in that one, I didn't know what to do either because I kept following like these projects because I wanted to build something cool. I kept falling like in like to this spiral of like tutorial hell, and I'm not even learning the basics of programming. Always learn the basics. Don't even start with C++. Start with C. The reason why you should start with C because C fucks you in the ass. And when you're programming, you wanna get fucked in the ass. Not like that. But like you want to get errors and try to problem solve it. If you have like a book solving those problems for you, you're not thinking. You're just like a machine, like following instructions. And programming and software is all about thinking. Like I made this. This is me thinking how this will work. So yeah, I think the first time I started to understand programming was like a year after that. Where I pick up C++ again, and I did like this Udemy course, like teaching the basic of C++, and that was the first time I ever felt enlightened. That was when I got in the zone, in the programming zone. I was like Vegeta, you know, when he wants to transform into like a Super Saiyan and he smashes the floor really hard and was like so angry that he managed to like unleash Super Saiyan. That was me. That was me with fucking programming C. I finally reached a programming level I can understand and do this shit. So yeah, that's my. What the fuck was I doing again? That's my story. We can even make it red, by the way, and you can see like look, see it works. So now next, what the fuck was I doing? We want to draw a square. So we're gonna make a function too. Void draw rect. And we're gonna make an SDL3 rect. We're gonna reference it. We're gonna pass this as a reference. We're gonna name it rect. And we're just gonna give it a color. So colors reference color. So we can do that. Yeah, let's do that. Let's do color. Because it's gonna be a rect. And what we're going to do is we're gonna do STL set render draw color to render color. So I need to pass in a render to STL render point to render. And the reason why I make this a pointer instead of like a reference is because since SDL render expects a pointer, so it's like I'm not gonna like make it be a reference and like do like this weird mumbo jumbo shit. It's a C library. Let me put in C. That's the beauty of C++. You can work with C and C++. That's the beauty of it. So renderer, we take in direct, and what the fuck? Oh, color, UN32, and then SDL render rect. So we take in the render, and then we have the rect. It was in the reference. When you pass in a reference, every time you gotta pass a reference here still is because the reference basically inside here, we basically are now making a copy, and it dereferences the value for us, and so we can work with like the dot instead of like the arrow. So then we gotta like dereference reference we gotta reference a dereference. That way we get the memory value. Yeah, I think that's it. And we cannot draw rect. So we're gonna make another struct. We're gonna name it snake type. And the snake is gonna have, we're getting into good stuff now. An f rect. I'm gonna name it body. And we're also going to give snake colors, called a color. What else? Should be it actually. And then what we do is we're gonna go here. So once we create everything, before running it, we're then gonna make a snake type. We're gonna name it snake. And snake body is gonna be, so the x gonna be 10. Excuse me. The y is gonna be 10. Width is gonna be square size because we want it to fill our grid. This is why square size like makes more sense, because we want it to fill a square in the grid. Same way height is gonna be the same. And then we go here, we do, so let's make it be in front of the grid. So draw rect, up, render. And we're gonna make it be color green. It's giving us, oh, you gotta pass in a rect, snake rect. In fact, let's make snake rect be body and snake color be the color. And what we can do now is make the default snake color be colors green. Yeah, and I love C++. So then I can run it. Oh my god. I can make it so we're compiling with C++ 20, but I'm too lazy. I think the flag is std equals C++ 20. But I'm not gonna do that. I'm just gonna do this, I guess. There we go. So you can see our rep, but you can see an issue here. We specified 10, 10, so the x is supposed to be 10, and like the y is supposed to be 10, but it's like stuck here, and it's like in between the thing. The reason why is because we need to multiply this by the square size. That way, it stays confined within our grid, and we're telling it to insert itself in like a square in our grid, which our grid follows a coordinate 2D plane. I mean, just fucking sure. I'm like talking like a fucking dumbass. Oh my god, I'm saying render. Hold on, sorry about that. You need to do render fail rect. That way it draws like a fail rect, rect instead of like a hollow rect. There you go. So if you see it here in our grid, 0, 0 is this one. It's the origin point. So if we go up here, it's gonna be 1, 0. We go here, it's gonna be 1, 1. If we go down here, it's gonna be 0, 1. So we're following like a grid. And in here, this is 10, 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, it makes sense, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our thing is correct. But let's say, what if it's bigger than our grid? What's gonna go outside? There is a way to fix that, and the way we fix that is by using modulus operator. And what we're going to do is, let's say, so we're gonna get the size of our row and our column. So how big is our row? How big is our column? So let's say our column is 27. If we do 10 times square size, what we first want to have a modulus of 27. That way, if the remainder is smaller than 27, it just returns 10 times square size, which basically says so our thing is contained within 27. Man, I'm like let me just show it to you. So we have construct function int, and we have the column. So column is left to right. I know if you like think of traditional math, you think column is like up and then up and down, right? Row is left to right. Well, in graphics programming, it's a little bit different. So column is left to right, but columns moves down. So the column is gonna be window width divided by square size, and this should give us how big our columns are. Same with row, you do window height divided by square size, and then you can see it here. The value is 27 and row is 20. And what we can do is we can have 20. We can make it so first 27 modulus 10 modulus 27 times square size. I put in parentheses, so it does this first times square size, and you can see unused variable call. Oh, whoops. So this is the y, so it's gonna be row. This is the x, so it's gonna be column. So modulus column, modulus row. You can see it handles the same thing. Now watch what happens if I make this be 30. It goes here. This is the math. Let me make this 10 again. This is how modulus operator work. I can actually show it to I got a. I said this is not gonna be a tutorial, but here I am like doing like a tutorial. So modulus works like this. I got a scientific calculator, so it has like a mod. So if I do 10 modulus 27, you can see it returns 10. Modulus just returns an integer. Not an integer. Modulus returns the remainder. So what it is 10 divided by 27. Well, the whole number is gonna be 0. The remainder is gonna be 10. So it just returns 10. But watch what happens when I do 27. In fact, I still 26 modulus 27. Sorry, it's 27 modulus 26. The fuck no, it's 26 modulus 27. I'm doing percentage. 26 modulus 27. You can see that remainder is 26. Then watch when I do 27 modulus 27. It's back to 0. The reason why is because 27 divided by 27 is 1 with a remainder of 0. You know what that means? It means once we pass our grid, it goes straight to the beginning. So we can watch this in action. 26 modulus column. At the end, right? If we put 27 modulus column, we're back at the beginning. It literally makes our thing stays inside. That's the beauty of modulus. So then 27 modulus, sorry. So like we have 30 modulus 27. 30 divided by 27, it can only go in one time with a remainder of 3. So besides we want the remainder, that's what the modulus gives us, where we're just gonna get 3. So yeah, that's how it works. Don't ask me how long it took me to learn modulus. To be fair, once I got to the zone, I like understood things so much better now. And that was like, oh my god, that was like 4 years ago that I got in the actually no, that was 3 years ago that I got like in like a good headspace to learn programming. That's why I always learn the fundamentals of programming first. So yeah, we got our square. I'm gonna put at 10. So it's right here. Let's add another one. Move a square. I should have done that. and then collision logic, and then draw snake, and then snake logic. So let's move the square. Actually, let me make it move as snake. Move as square. Yeah, I'm gonna name it that. So we're gonna have void move snake. And what we're going to have is we're gonna have the snake type reference snake. I think that's it. And what we're going to do is we're gonna have yeah, so we want to also have the key state, so constant pointer, but a boolean is a an unsigned byte is a byte, but it mostly handles true and false. But that's what the key state is in SDL. I kind of like if you see me do UN8, like it doesn't work. It has to be a bow. So yeah, constant pointer key state, and we do if key state SDL scan code W. If key state SDL scan code S. If key state SDL scan code A. I can actually just do up down. Let's do up, down, left. If key state SDL scan code right. What we're going to do is we're going to make our snake that by that x, well, sorry, y. Since it's up, we're gonna move up by a square size because we wanted to move by each square of the grid, so we don't have the issue we had at the beginning. So we're gonna do the same for all these, and we're gonna put this as positive because positive is going down, left is right, and we just gotta change the x. And this one, since we're going right, it's positive. Then we have in here move snake. The snake is gonna be snake, and the key state is gonna be key state. And now we go up, and we have an issue. What is that issue? Why is it dying? So when we move it, I don't know why I'm getting an issue of this. But yeah, let me just take this, put it here. Alright, let's see. Key state. What? What? Oh, move right. Let's just do this. Actually, I can use the comment region. There we go. Ah! I see the issue. Okay. I see the issue. We have it like how we did. Okay. And what I'm going to do this time is have an SDL delay of like, I don't know, let's make it be a big number, 266. Run it again. We press up. Jesus Christ. Up. Oh my god, what the fuck? It's 260. That was too big. So you can see we move, but if we like hold it, it's fucking fast. And also, snake, it shouldn't work this way. It should work by directions. So let's do that. Don't worry, we're gonna tackle this issue later on. Let me just do directions first. So snake moves by direction. So we're gonna make a enum class called directions. You can see it handles in, and we're gonna have up is 0, down, left, right. If you don't know how enums work, first of all, I think you should just like leave the video and just learn programming. There's a website called Learn C++, learncpp.com that can teach you C++ programming. It's a really good website. I recommend you learn that. But I'm still gonna like say the basics in case you just don't want to feel like doing that. I think it's important to know. So in enums, you can like make a variable, and if you assign the like, let's say 0 to like a variable here, I like to think of it like that, like a variable. Whatever comes afterwards is gonna be an incrementation of whatever's below. So 0, so since before, so down is gonna be 1 because up is 0, but we can also specify down to be 3, and everything afterwards, if we don't specify it, is gonna be an incrementation of things that came before. So since down is 3, left is now 4, and right is now 5. Also, you can see directions essentially integers. We don't need something to be an integer. I'm just going to make it be a uint, or you can even say unsigned char, because I don't need a number to be big enough to be an integer for directions. I'm just gonna call it uint, which is basically a it's basically a byte. We're gonna make it be an unsigned byte, and we're gonna give snek direction, and by default the direction is gonna be directions up. And instead here, instead of like moving it when we press up, what we're going to do instead is make snek direction be directions up. And then, so we press down, direction is going to be down. If we press left, direction is going to be left. If we press right, direction is going to be right. And then we're going to make a switch statement of snek direction, and default, it gives an error because it doesn't know how to handle anything that's not part of it. So you can see like how to handle up, down, left, right. We gotta make a default. When it fixes it, it knows that when it handles something, it doesn't see into thing. It's just gonna break. So case directions. Whoops. Directions up. So if the snek direction is up, we're gonna move the snek.body y up by a square size. It's gonna be the same case with the rest, but with their specific directions. If it's down, plus equal. If it's left, it's gonna be x minus equal. Right, it's gonna be x plus equal. So we do this, you can see it's working perfectly. This is how snek should work. But look what happens if I take this off. That's the delay. You don't see it. You can see me press up and down, and you see like maybe like a flash of it. The reason why is because SDL delay, all it does is like, whoops. All it does is delay the rendering by 6/60 on a by microsecond. So 60th of a microsecond is how much I'm delaying this by, which is basically telling us our thing is running too fast. We're now going to handle FPS, frame per second. So let me just remove this. I made a video about this on how I handle FPS in SDL3, so I'm gonna like go over this as well in here. I'm sorry, I'm just like fucking beatboxing for no reason. I don't know where to make this be at. Let's make it be below the row and column. So I'm gonna have an FPS of 60. I'm gonna make it caps. I'm gonna make it 60, and we're going to have a draw interval, which is basically how many times are we going to draw it by. So SDL3 has a get ticks function, which is what we're going to use. SDL get ticks. You can see it also has get ticks 64. So get ticks, let me just do double A. It returns a UN64, so double is not valid. It will be in UN64 is an unsigned long, by the way, which is why UN64 is. It comes used for UN64. And you can see, it gets the number of milliseconds since the SDL library got initialized. If using SDL2, this one instead return a 32-bit value, unless you use this SDL get ticks 64. But in SDL3, they removed and just made it be SDL get ticks. They also have nanoseconds, but I'm not gonna get into that. So the math for this, just first, it's gonna be double draw interval. So it's how much we're gonna be drawing by, and since we're dealing with milliseconds, a millisecond is 1,000th of a second. So divided by FPS. So we get the calculator out. Get the calculator out. Divided by 60. So we're going to be drawing 16.666667. I think it's 16.67. Every fuck, I forgot about this. Every I think we're gonna be drawing that we're going to be. I actually have to do it because I'm gonna be lost. So we're gonna be drawing a frame every of that millisecond to get 60 frames in 1 second. Yeah, that's what it is. I'm like, okay, I got it. I was thinking of how I'm gonna implement this, and then I got like the idea. So we're gonna draw a frame 16.666667 of a millisecond. That way, when we hit 1 second, 60 frames should be drawn. Yeah, 60 frames should be drawn. Don't worry, I'm gonna like put this in code because I know I'm garbage when it comes to explaining something. So what we're going to have is we're going to have a we can say unsigned long. So unsigned long previous time. Let's do it this way, the C++ way. And it's gonna be SDL get ticks. If you're in SDL2, you're gonna have to use SDL get ticks 64. If you're in SDL3, you can just put get ticks. And then we're also gonna have an unsigned long current time. It's gonna be empty for now. This will start once our game loop begins. We're also gonna have the delta time. Delta time is gonna be our frame time, and we're going to have an elapsed time. Elapsed time is going to be our original time, our full time, our elapsed time. It's in the name. The time that has passed. I think that's it. So then what we do is when we begin our game loop, we're gonna have current time be SDL, get the current value of the SDL ticks. Delta time is going to be current time minus previous time divided by the draw interval. that way this is tied up with how many, with the frames, because remember delta time is gonna handle the frame time. So 1 delta time is 1 frame being drawn. 2 delta time is gonna be 2 frames being drawn. Then we get the elapsed time, which is gonna be current time minus previous time. And since this is just gonna be the total time, we don't have to do anything else like draw interval, because draw interval is just want the frames. We just want this one to like the time, the full time, and then we make our previous time be the current time. So we get like this nice loop. Oh, one more thing. We gotta line this up like this. We're gonna increment it. That way when delta time hits 1, that means we're ready to draw a frame. Yes. So then we do if delta time is greater than or equal to 1, that means a frame has passed and we should begin drawing. Oops, I gotta do it this way. Boom. So we're gonna put this all inside. We're gonna put our update and our rendering inside here. So then now, once we hit a frame, we're going to draw it. Oops. Elapsed time set but not used. Okay, that's just so fucking annoying. Let's just do fucking void elapsed time. I think that's there. Hold on, I'm gonna sneeze. Okay, I sneezed. You can see it's still like not showing up. That's because we need to do this. Frame time. Oops. We gotta reset the delta time by 1. So then we can run. Oh my fucking god! Void elapsed time. And now you can see. Look at that. Now our thing is running in 60 seconds because it's still too fast. But don't worry, we'll fix that. So for you to believe that it is running in 60 frames a second, I'm gonna make another variable called int32. That's gonna make int frames. Keep it simple. Keep it simple for you guys. And what that's going to do is, every time a frame is drawn, we're gonna increment frames. So every time a frame is drawn, we increment frame, and then when we hit a second, so now we can use elapsed time. Whenever we hit a second, so remember a second in milliseconds, since that's how much we're counting by, since that's what SDL3 gives us. It gives us milliseconds. You can see I get the number of milliseconds as SDL library initialization. So a second in milliseconds is gonna be 1,000th. So once a second has reached, we're gonna make the elapsed time go back to 0, and then we're going to SDL log. You can also use printf or SDC outs or SD print if you're in the future, like watching this one. We have an actual print function in fucking C++ instead of fucking C out. You can like print it with like this U. Well, it's an integer, so D. At the new line, so it's going to put FPS, and then we're gonna have frames here, and then we reset frames back to 0. So if we run it now, you can see 60, 60, 60, 60, and if we make this be something like 30, we'll make the frames be 30. Oh fuck! You can see the snake is running slower, and our thing is saying 30, 30, 30, 30, 30, and 30. So yeah. We can also handle this in nanoseconds. SDL3 gives us the function, but I don't really think there's a reason to, and it's just more easier to, well, at least for me, it's more easier to handle it in milliseconds since I understand that better. But you don't really need to. You don't need that insane amount of precision. It's just a fucking snake game, so relax. But you see, our snake is still running too fast. We're gonna have to slow it down all the way to 8. Right now, see, now this look good, but you don't want it to run in 8 frames per second. You want it to run on 60 frames. So you just want to like slow the snake down. Is there like a way that we can like make our game run in 60 frames, but our snake moves much slower? Yes, we can. Yes, we can. And I think this is what the game industry does to handle things. They handle like things separately. Because remember, our elapsed time is the total time. Our delta time is the frame time. So what if we want to make our snake move every 8th or 6th or 4th of a frame? So every time 4 frames are generated, that's when we want to move our snake. So everything else moves at 60 frames per second, while our snake can only move 1/6 of a frame, 1/6 of 60 frames per a second. Hope I'm saying that right, but I'll show you what I mean. So in our move snake, we're gonna give it 2 more parameters. So I gotta scratch my ear. Oh my god. We're gonna give it double delta time. We're gonna pass it our reference. And we're gonna give another one called time to move. Snake move time. Let's limit that. And what this is going to do is snake move time is gonna get each delta time, and then once the snake move time reach 8, we're gonna do like AF. That's when we want to call our snake move function, our switch statement for snake. So you can see what's happening here. I hope you can see it. Delta time handles our frames. So 1 delta time is 1 frame generated. 60 delta time is 60 frames generated. So if we keep the delta time, we pass in each time a frame was generated to snake move time. The minute delta time generated 8 frames, that's when the snake is going to move. So it's gonna move 1/8 of a frame. So everything else is moving at 60, but the snake is moving 1/8 of a frame. So now we gotta pass in those parameters. So we gotta pass in the delta time, and we're also gonna pass in the snake move time. I think that's what I named it. Snake move time, yeah. And snake move time is just gonna be a parameter here. We can put it here. Double snake move time. And that should be good. That should be it. So we got it right there. So now we run it. You can see. Oh, sorry about that. You have to reset it as well. Snake move time is 0. We reset it, and then we like keep the loop. So now, boom. Everything now is just moving at 60, but our snake is moving 1/8 of a frame of second. So what if we put this at 60? Check what happens. So we make this be 60. Look at that. Every time a second passes, that's when our snake is moving. So what's double 60? So let's make it be every 2 seconds our snake moves, which 2 seconds, as we're doing frames per second, 60 frames per second, is gonna be 120 frames for 2 seconds to pass. Look at that. Fucking gorgeous. But we want our snake to move a little bit more fucking quicker than that. Look at that. So now our snake is moving 6 of 60 frames a second. That's how we separate our time. I hope that helps. It surely helped me because I was very confused when it came to FPS, and I was like seeing like this Java video of this guy like making like a game like Java, and he like had like this thing. And holy shit, I like implemented my own in like SDL3 instead of Java, because I'll be honest, I'm just so shit at Java. I'm really bad at it, and I understand C++ and C syntax much better. So I like implemented it in C++, even in C, I think, because like SDL3, SDL2, I did it on SDL2. SDL2 worked in C and C++, same with SDL3. So I did it that way, and I gained a lot of knowledge from doing it, experimenting. So if you are still confused by this, experiment. You can put this in like another language, and maybe you'll get it. You can ask ChatGPT to explain it to you. He probably does a better job than me. Now, I don't recommend you rely on ChatGPT, but if you can like tell it to like explain something to you in like a certain way, I think it does a solid job at that. So you can try that. Anyway, we got our snake. Now we need an apple. So I want to make a struct apple type, and an apple is going to have a body, and it's going to have a color. By default, I'm going to make it be color red. By default, it's going to be color red. So an apple is gonna work the same way as how we plan our snake. So apple type apple, and then we're gonna have apple that body be something like, I don't know, like 10 column, and it's gonna be square size. Oh, sorry, time. My God. Okay. Shit's getting complicated now. To have it written that way, we're gonna have apple body that x being 10% column time square size. Apple body that y. Let's do 5% row time square size. I said percentage. 5 modulus row. Apple body width is gonna be apple body height, which is gonna be a square size. Remember, in programming, things go from right, at least in C and C++, it goes from right to left. So, W is H, which is square size. So 24 is going to be height, and width is going to be height, which is 24. So then we can do draw rect. Let's draw behind the apple. So we have app renderer, apple body, and apple color. So we call it, boom, we get it. But we want it to be random. Well, we're gonna have to randomize it, and we're gonna do it with the random class in C++. The random class, the random library, the random header from the central library. If you're in C, I think you include time.h, and then you do srand time no, and then you want to like modulus it with like the time or some shit like that. But in C++, that's how you do it. So we have random. So we need to create a random device. Let me do it. Let's make our random device here. Random, and yes, I'm gonna make it be a global function. A global, not function, a global variable called RD. And what we want to do is we want to seed this random device to an algorithm for generating more high quality random numbers. And one algorithm is the Mesmer Twister engine or some shit like that. You can read this in you can like read it in documentations. Here it is, Messani Twister engine. I think it's MT 1937. I'm gonna do 1937 and not 64. So 64 returns an unsigned long. The normal one returns 32, an unsigned 32-bit. Or a signed 32-bit. I don't remember it that well. But I don't really need a really big value. I'm gonna keep it small. And I'm gonna name it gen, so it can generate a seed. And it's gonna take in our random device. So it's gonna generate a seed with the algorithm for the Mesmer Twister engine from the value generated by RD. So it can give us more precise pseudo numbers. And then now we're gonna go here, and what I'm gonna do is let's go here. So after we initialize SDL2, we're gonna uniform int distribution int this, so the distance is gonna go from 0 to column. Since column is the biggest number in our grid, I'm just gonna do column. You can do 40. Remember, you got the modulus, so you got the modulus with like the row or the column, so you don't really have to worry about how big it'll be. But I recommend just doing it like this way. You don't really need a big number. Can I make this smaller? Sure. I can. Okay, U and 8. Yay. So I'm gonna do U and 8, and then what I can do is apple.body.x is dist gen. There we go. Dist gen. So it'll generate a number from 0 to 27, and that's what column is. And then now when I run it, boom, it's random. Oops. We got our random number, our random generated number, and it's gonna stay within the thing. So now we need to handle collision. So we got move a square. We can draw a square. We got our apple. Now collision logic. Okay. So void apple logic, and we're gonna get our apple type and our snake type snake. And what we're going to do, so if SDL has like a built-in function called SDL has rect intersection, which is basically detects a collision between two rects. But I don't like it. It's not that precise. So what I'm going to do is gonna make my own function. Gonna make it be a boolean called AABB. So we're gonna do AABB collision, and it's gonna take in a constant SDL f rect, and we're gonna name it. We're gonna reference it. We're gonna name it A, and a constant SDL f rect. We're gonna name it B. Okay. And what we're going to do is if a.x is greater than or equal to b.x minus shit, I think no b.width and a.x plus a dot width is less than or equal to b dot x, and shit, I completely forgot to do this. A dot y is greater than or equal to b dot y plus b dot. No, we're gonna have the x maximum and the x minimum. Greater than. Okay. With the height and a dot y plus a dot height is less than or equal to b dot y. Going to return true, else return false. I'm not gonna do an else. Then I'm gonna do if AABB apple body and snake body. Then what we're going to do is we're going to SD uniform in distribution UN8 this 0 column, and we're going to make the apple body dot x be dist gen modulus column times square size, and the y be row times square size. And then we're going to handle our apple logic before move snake, and it's gonna take an apple and snake. Oh shit, I got it wrong. I got my ABB wrong. With plus a minus b. I think that's it. Oh man, I forgot to do this shit. It has escaped my mind. Okay. Is it or? So if a dot x I have not practiced that much with AABB. All I know is x maximum, a maximum, a minimum, b maximum, b minimum. So a minimum would it be equal? It's not equal. Still like this. Ain't that? Wait, W. And e minus a by is it or? No, it's not. Holy shit. Okay. if a dot x, so if the apple x position data reverse. I do not. Let's look it up. AABB formula. Greater than the box minimum x. Greater than or equal to x minimum x, and then greater than or equal to x maximum x. Is that it? Okay, so I think it's just the same shit here. E dot x plus E dot I. Ah, there we go. What? Is it off? The fuck? It's off. I can't tell. Hold on. Oh god, I'm about to sneeze again. When I go on the left. Hold on. Okay. Let's read this formula again. Okay, this is with Z. We're handling 2D. Oh! Oh, man. Minus. Okay, there we go. Oh my god, that's not good. Hi. Okay. La conta paro. Okay. So when I went down right. Eta man makes the Y. Eta man. Okay, so the minimum of X is greater than maximum. Minimum X is greater than or equal to maximum of minimum X greater than or equal to maximum of theta. and then and maximum of a maximum square term equals the minimum beta width. Sorry. Jesus Christ. Okay, it's just not working well. Okay, maybe this just sucks. What about this one? A, B, B. So box left is greater than box right. Box right is greater than box left. Box top is greater than box bottom, and box bottom is greater than box top. So this is gonna give us... I can see, I'm a fucking idiot. This is gonna give us the left of the box. So if the left of the box... Yes, okay, if the left of the box is the right of this box, and the right of this box is the left of this box, and the top of this box, the top of this box, the bottom of this box, and if the bottom of this box, not to be minus. So if the bottom of this box so this is the left side, this is the right side, and this is the bottom. No, this is the right, the X, and then this is the top of the box. This is the bottom of the box, and this is the top of the box. Where's it the bottom? Is it like this? Shit. Oh, okay, I gotta pee. I'll be right back. I'll like research more on this. I'll be right back. Okay, I finished taking a piss. We're not gonna do much research. Where was I again? Okay. The left, the right, then the right, the left, the left, wait a minute, the left is the, so if the top is less than or equal to the left, the AY plus height, which is the bottom, the fucking bottom, is greater than or equal to the top. Wait, is it actually, was it correct this whole time and I was just like being an idiot? It feels off. Okay, okay. Maybe it's the fucking equal signs. Let me remove that shit. I swear to fucking God, it was the fucking equals. How does that even make fucking sense? How is it the equal signs? I'm trying to like, how the fuck is it? I thought the equal signs will make it be equal. What? How are the equal signs like one? You what? Okay, well, anyway, man. Anyway, we got it. Okay. Oh my god, there's no equal signs here either. That's probably how I got my fucking idea. I probably like thought of it out of like seeing this shit. In here, they have the fucking equal signs. Oh my god. Okay, alright. This is more accurate. This is more accurate. Okay. Okay. Alright. Okay, we got our AABB2 collision. AABB collision. Look at that. Works fucking perfect. After fucking now. Okay, now what we want to do is in Apple logic, we also want to handle that word like snake logic. Collision logic, we have it. We gotta draw snake. Okay, I think what I mean by that is we first have to. So now, how are we going to make our snake grow? There's a couple ways you can do this. Basically, we want to have a continuous. I'm sucking away from the mic. Sorry. Basically, we want to have a continuous segment in memory, like an array. That I'm like thinking in my head, like picturing in my head. It's like an array, but we cannot have an array because we need memory allocate. We need. I'm thinking like malloc. What the fuck is malloc again? We need a segment. No, segment form. Something else. We need malloc. What is a malloc? God damn it! Just tell me. Man malloc. Malloc returns allocated memory. We need heap memory. Okay. Jesus Christ. We need heap memory. We need dynamic allocated memory. Oh my god, okay, it came to me. We need dynamically allocate memory instead of like fixed memory. We can also use vectors. Vectors like the easiest way to do this. Excuse me, but I want this to also be more understandable and also like easier for people who are using C to learn. People in C do not have a vector; they have a pointer. So what I'm going to do is we're going to make a linked list. Snake type and pointer next, just like our recursion. And what we're going to do here is so our next by default is going to be a no pointer. Look at that, we're using no pointer now. It's not gonna be no. If you didn't see, you can also use no. Okay, you see you can also use no. I think it's the same shit. But you're gonna use a no. You're gonna use no or no pointer. By default, it's gonna be a no or no pointer. And what we want to do is when it touches the app, we want to allocate memory to the next one. So we're gonna make a snake type current. We're gonna name it current. I think this is like the traditional way to like make a linked list. By the way, I recommend you look into linked list, especially if you like doing C stuff. The very important thing to know, you should know linked list. And we wanted to point into the address of snake. And then no, we're not gonna make it point to like the next. The reason why is because we want to allocate memory into snake.next. If we and to do that, you need to start at the beginning and then make your way there. If you just like point to it to like the empty memory and then you want to like allocate to that empty memory, first of all, the problem with this is that the problem with this is that let's say we already have allocated that next. and then we're like pointing to the dot next, and so then from the dot next, we're pointing it with current. So then with current, we gotta like access the next area of memory of the dot next. I don't think, if I remember correctly, the program can't do that efficiently. You have to make a point to like the beginning and then move your way there. I think that's it, if I remember correctly. Because I'm thinking of assembly. In assembly, you do this. You point to the beginning of the address, and then from the beginning, you kind of like make your way to like the end. Or maybe just like think of some other shit. But basically, maybe if I like visualize it. So we have our snake here with like data, and then we have like this empty snake here, no data, and we have our current pointing here, and we like fill it with data. And well, we also want to fill this current with like whatever the previous segment was. So what if we have something like, okay, this has data now this is empty. Well, how do we get this? Because if we point to that next and current that next, then we like go back to this. Would that work actually? No, it won't. I mean, we can try. Fuck it, let's try it. Let's point to that next. So wow, current that next is not. This is the issue. Current that next is not no pointer. But the current value is already a no pointer. So I guess we can do this. If current is a no pointer, then we allocate current equals new snake type, and current the body is gonna be snake body, and then current next is gonna be a no pointer. Else, while current that next is not a no pointer, we're going to increment it. So current is gonna be current next. And then current next is gonna be a new snake type. So then current next body is gonna be current body, and then current next is gonna be no pointer. I think that's it. Okay, I think that works. Okay. And then we want to free it. We want to make sure to free that. So snake type pointer current is going to point to snake next. And wow, snake that next. Jesus. I want it. Next. Wow, current. It's not a no pointer. Delete current, and then current is gonna be current next. I want to make SDL log read. Does that work? See, this is not working. So let's do SDL log created apart. a steel log, a newer part followed old hollow part. We touch it, create a part, and then create it apart. See, that's what's happening. See, this has to be a double pointer because we gotta modify, because we're pointing to like this area of memory, but we're only taking in a copy of that value. We have to start at the beginning of the address. First of all, yeah, let's do that so we can like get rid of this shit as well. Jesus Christ. And then from there, while current next is not a no pointer, we can wait our work down. So current is gonna be current then next. So then we can do is current equals current then next is gonna be a new snake type. Current that body, well, that body is gonna be the current body, and then current next is gonna be a no pointer. See, look, it caught it. Okay, it caught it. See, now, okay, oh my god. We're pointing to like the original address, and then from the original address, we're going down. Because that's how it reads it in memory. It starts it from zero, and then from the first address it goes to the next address. If we go immediately to like the other type, we're just getting like a copy of the other type of the other address to current. I think the only way to handle it will be like with a double pointer to in order to, but I feel like that's just so fucking complicated, and I'm probably not even making any fucking sense. But we gotta start at the base value. Maybe somebody else will fucking explain this better. Maybe I'll have like somebody in the comment be like, actually, it's actually done because of this, and they're probably explaining it way better than I can. You can even do your research. But it's already fucking 3. I'm spending so much fucking time in this shit. My god. But yeah, now it's working because now our freed is being called. But you see our snake is not being drawn. We need to make a void draw snake function. SDL render, and we're gonna have the snake type. Reference snake. And then SDL set render draw color. Actually, we can have draw rect. We can have render and then snake that body, snake that color, and then have a snake type current point to that. I think we can do a copy, and while current is not a no pointer, we can have draw rect renderer current body, current color, and then current is gonna be current next. And then we can hide this, and we can have draw snake, app render, and then snake. Okay, I don't know how good that is. That's probably, oh my god. Let's make it at the first one, and then next. What the fuck? Well, I can hide this and just make it draw every of them. Okay, that also works. So even draws the snake as well. Yeah, I'm gonna have that. I think that's just so. So now when we do this, hopefully this is just. I figure we'll like make a. You know what? It probably doesn't remember the previous part. So we move snake. Well, we can have a. Let's make a vector too. Struct back to F, and it's gonna have a float X and Y. 0, 0 by default. And we're going to keep track of the snake. So back to F, snake pause, pre-pause is going to be snake pre that X. So it's gonna be the snake body dot X and the snake body dot Y. And then all the one at the bottom. Yes, it's up on the bottom. We're going to have a snake type parent be snake.next, I think. Yeah, because we shit. I think it's the reference. While current is not a no pointer. No, we wanna handle the current one. So what we're going to do is a vector F of prev snake per pause. So the snake current pause is gonna be the previous position. Wait, no. The snake current position, that X is gonna be the current body, that X. Snake per pause, that Y is gonna be the current body, that Y. And then the current body, that Y, that X is gonna be snake previous position, that X. Current body, that Y is gonna be the snake previous position, that Y. What the fuck am I doing this right? Yes. And now the previous snake previous position is gonna be the snake current position. And then we go to the next one. I think that's it. Yes! Oh! I'm such a fucking god. Oh my god. Okay, you can see that the grid, there's no line. That's the reason was because I'll be honest, I winked that shit. I was like just thinking, I was just like thinking like not even like fucking there. Whoops. We gotta put our snake behind the grid. Still Oracle as well. I like making the apple be behind the snakes. The snake comes afterwards and overlap the apple. Yeah, you cannot see the grid. There we go. Oh my god. And our freed is our thing is being freed too. So we don't free the snake because the snake is allocating the stack. So we point to the next, and if the next is no, then we delete the current, and then we move on to the next one. Man, how does that even? So yeah, our snake logic. I'm probably confusing you guys more. I forgot how this works. So we cannot point it. I think it's because it takes a copy. Because this is just me, like, from memory. Like when I used to work with linked lists before, and I even tried to make snake. But that was like on my old PC, so I went to like make it in my old PC, in my old operating system, because I used to be on a DevOS. Now I'm on a Catch OS. And like I didn't like bring that with me. I went to recreate it. I remember I did it this way because I did it first in C. So with C, I probably didn't have to. In fact, with C, I made it be a pointer. Fuck, I don't remember it. But when we did it like this, it gave us an error. Well, not an error. It just like didn't create it. It just kept recreating the same thing, and I think the reason why and our feed wasn't even like caught on. And I think the reason why is because we're making a copy. Since in C, everything works like a copy. So we'll probably make a copy of that memory address, and we weren't able to modify it. But if we point to the stack memory, because this is stack memory, our .next is heap memory. So if we point to our stack memory, then from our stack memory, we can then access our heap memory. I think that's it. And that's why this worked instead of our .next working. Okay, I think that's it. I'm so glad that ABB was that simple. I mean, to be fair, I also had to like look it up. Okay. This is our. So what we're gonna do more? We're gonna do draw snake logic. We have that bonus score system. There's also cheat codes. Guys, I don't know if we're gonna be able to do cheat codes. I mean, I can probably fuck it. Fuck it. Oh right. We also need like a game over system. I think I'm gonna add that. So when we do this, like, how are we gonna die? How are we gonna call game over? Like, look at that. We're like overlapping with our snake. Oh, I can't even go and explain my my movement thing. How I thought of it. Where is the move snake? Okay, so what I did here was so the way this works is we capture the position the snake is originally in. So before we move it, we capture its original position. Then when we got the original position, and once we moved it, I made a vector 2 to capture the current position. And the current position pointed to the next. I mean, sorry. So then we keep track of the next of the next like segment of the snake. So if the current segment is not a no pointer, we're gonna do this. Otherwise, I guess we do nothing. Something. There we go. But let's say we got our value. We created a snake type for the next. Well, it's gonna see that it's gonna be okay. Well, it's not a no pointer. So what we do is we copy our current position that the current value is in. That and we make it be our we capture it. When I think of this in my head, and then I'm also really bad at explaining things. And then we get the current position that it's in, and we put it with the previous one that it was. And the previous one is gonna be our current position that the snake is in. Wait, do I even need this? Hold on. Yeah, I do. Okay, I fucking do. Yeah, for the previous one. I guess this doesn't work with this one. Yeah, so I can see the so I can see the loop here. And that's what I did. Okay. And then I move on to the next of the list, and then we like modify it the same way. We get the current position. The current position is going to be the previous position that it was. The previous position is not the current position. So it takes in the previous position of the segment, and it makes it be the current position that's going to be, which makes it look like like they're following each other. Now for what the fuck is it? The pain point of making a score system in SDL3 is that I need to include like an SDL TTF and then have to like add like shit with like the TTF. I'm not gonna do that. What I'm going to do is I'm gonna change the title. The title is gonna like be renamed to match the score. I can also make it be a log, so like keep track of it. So like every time we eat the apple, like a log will show up, be like score is 1, some shit like that. I'm not gonna do that because we also are counting our FPS, and it'll just look messy. So so what I'm gonna do is in our apple logic, when we touch an apple, I'm gonna make a score here called int score. And this is gonna be static. That way, it exists. That way, it is scoped, but the data of this remains. And when we eat the apple, our score is gonna increment by 1. And then we gotta set SDL set window title. Oh, we also need the window. So we're gonna pass it here, SDL window pointer window. SDL set window title window to score. You can see that it needs to take in a constant char pointer title. You can make this work in C with S and printf, but we're using C++, and in C++ what we use is string stream. Oh, it's actually called SS stream. Yes, SS stream. That's what it's called. SS stream. And what we're going to do is we're going to make we're gonna increment score. I'm gonna do it this way. That way it doesn't like make like a copy. And we're gonna call SS string stream. Okay. Score stream. I'm gonna name it score stream. and then fuck, I forgot how this works. So score stream is gonna take in the data of score. I almost named FPS. And then score. And then in here I do score stream string. And it's an okay, I gotta go with them. App set window title. And we gotta make this be. It says set window no matching function call. String type string. Oh, it's probably using like a C++ string, right? Can I turn into a C string? I can, okay. Yeah. Okay, there we go. So now if I run it. Yes, okay. Okay, there we go. Huh. So now you can see our score is matching the thing, and it doesn't like reset. See, check what happens if we take away static. It'll reset like the score to 0. So it's gonna be 1, then it's gonna be 1 still, because it's stored locally. Once this dies, every variable here dies as well. But if we have static, it's gonna exist until we close the program. So it'll keep the data, and it'll be scoped. So that's how so you can make a score system with like the title. Oh, we also, my God, I even forgot to implement like if you like collide with yourself. I'm sorry about that. I'm like so fucking jumpy. I don't know where to put it. So we get the position, we move it, we capture the position. We also want to check if AABB, okay, we're getting somewhere. Snake body touches the current body. Yes. So if the head of the snake, oh my God, this is so fucking good. If the head of the snake touches the body of the snake, because remember, our main body is the head. Then we want to like exit it. So we want to make I'm gonna pass in the struct. See, I have C brain. I'm putting like struct snake type because I have like C brain. I've been coding in C for like a while, and I got like used to it. But I'll be honest, I prefer coding in C++. So, but because I'm like using SDL and like C++, I do like some C shit, like some C++ shit. Struct, what the fuck else? App. SDL app type. There we go. SDL type. Referenced app. And for the app, I want to do app is running be false. Then I move snake. There's the second argument. We pass an app here. So now, oh, there we go. that was quick. So see, we can go up and down. We have one part we can go up and down because we're not touching a segment. So if we touch this one and I try to go like on the bottom, or like I try to touch myself, not like that. All right, not like that. They access that game. Even better, can we show you with the so like if I grow big enough. If I grow big enough and I end up touching myself, it jacks in the cake. Oh man. And it frees everything. Oh man. Oh my fucking god, it's so stupid. Oh god. Oh my god. Oh my god. Okay. Alright, that's how you Oh right, that's the cheat codes. If you wanna make cheat codes, if you want to make cheat codes, you do in char argc char pointer argv. Actually, that looks weird. I'm just gonna make pointer pointer. Or I think you can also do pointer pointer. You can make it be like, so if argc is greater than 1, that means if there's 2 argument, if argv equals 0 0, oh shit, if so, we're gonna have SD string sheet code be argv0, and if cheat code compare is equals, okay, I can do that. Okay, thank you C++, making life easier for me. If cheat code is speed, then what we can do is we can make our what can we do? I guess we can change our FPS to be something like 120. Right is a constant expression, so I cannot change it. I can make, if cheat code equals speed, I was thinking of making like the snake speed be like higher. That doesn't really make a whole lot of fucking sense. Okay, I got it. So I'm gonna make score be a global variable with static, and what I'm going to do is if you put score me, it's gonna make score by default have a value of 100. So then if you like so if you launch the executable with a parameter of score me with a if you launch it and you put an argument of score me, when you get like 1, okay, that did not fucking work. Shit, I did not work. Maybe it has to be like with semicolons. Did not work. Still log parameter am matched. Also, I initialize still, so use Go like this. Okay, it didn't call it. Okay, I'm doing this fucking wrong. 2-1? Am I stupid? What the fuck? Damn match. Score is 100. See it. SDL log. Cheat code. Cheat code. Cheat code. Ah, that's why. And the first argument, which is snake. That's why I was wrong. Okay, okay. Okay, now it should work. Cheat code to score me. There we go. Okay, there we go. So as you can see, look at that. You start with like score 101. And this is how you can implement like cheat codes to your game. With like arguments. And then we hit ourselves. Oh. That's how you implement cheat codes in your game. So that's our cheat code. What else for cheat codes can we have? I guess we can have something like smaller squares. And we can do like let's say else if cheat code equals smaller square. Smaller square. We can have it so square size. It's a constant. Let's not make it a constant. Let's make it an integer. Why is that annoying me? Son of a bitch, because it is. I guess this is also not a fucking. Oh, it's having issues. Everything's having issues now. Insert an explicit cast to silence this issue. I think I know why. Hello? Fuck. I made my thing too strict. I don't really feel like changing this. Why? Non-constant cannot be narrowed from int to float. Son of a bitch, because that's what it takes. I'm just gonna make it a float. 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 What now? Square size. Oh, equals 40. Modulus, son of a bitch. Why is it annoying? Let's just like remove this. Oh my god. Implicit cast to silence this issue. Swap operands to what? I get what it means. Isn't that a fucking flow? Oh, it isn't. Okay, flow. Wait, I'm sorry, guys. I know I'm like changing all this shit. You know, it's taking long. I'm not even skipping it. Okay. So I put score mean. Now if we put the smaller squares, you can see. Well, that's bigger squares. I guess I have to make this smaller. Where is it? So we have 8. Oh my god! Look at that! Probably couldn't even see that. Let me make 16. That you now have smaller squares. So that's a way, and you can also have you can also make it be like a for loop if you want to, like, so for auto. No, sorry. So for as the string cheat code. Int I equals 1. We want to start at 1. If I is less than argc, which is the argument count, increment I. And then what you can do is you can have if arg I a is arg I, and then you can have if cheat code it is score me score equals 100. Else if cheat code equals smaller, if cheat code equals smaller squares, square size is 16. So then we can have smaller squares and score me, and you can see both were applied. Both cheat codes were applied. So you can, like, detect multiple cheat codes this way. If you only have like one cheat code, boom, boom, it still applies that one cheat code. So that's how you can have like cheat codes in Snake. That's how I do it. Maybe there's like other ways, but that's how I do my cheat codes. If you get annoyed that when you go out of bounds to in your Snake, like nothing happens, you can probably make like a function in here, whereas if edge of screen, do something like that. What I like to do is I like it so, like, let's say I go up, and if snake.body.y is 0, it's less than 0, then what I like to do is make the snake.body.y be the window height minus square size. So we go up here. You can see it goes on the bottom. But let me actually move this. So we go up. Okay, okay, maybe not this. I don't need the offset. You can do something like that. I kind of like doing something like this. You can figure out how you can do it for the rest. You can see I also don't have the columns, not the columns, the modulus, so the thing is going off the screen. So yeah, that's how you make Snake in C++. I hope it helped. I'm gonna fix like a bunch of that shit. Like I'm gonna put this. I'm gonna make me int constant expression int column. and grow. It's not gonna be a float. I'm gonna fix all of that, but I hope that you enjoy. This was me making Snake. It's 3 fucking 41. It's like 2 hours long. Honestly, it could have been shorter, but I was just like fucking around and and like putting and like doing shit. It should have taken us 1 hour, but yeah. So, yeah, I hope you enjoyed. I had fun. I have fun making this, not gonna lie. If it's fixed now, it's not because I got the argv arguments. If you wanna write like these arguments, but you're not using anything, you can just do void argc, void argv, and it should stop bothering you. See? Snake also moving it on its two modulus column. So I think that reason was arguing with us when we use this with modulus and column and row. It's because I think these work with like compile times. I don't know about I think modulus only works with integers because it returns remainders. It returns a remainder, I think. You can always just look that up yourself. It should work now. But yeah, that's the importance of having like the modulus operator. You can see how it wasn't even like showing up, and now I got the modulus operator, so it is showing up. So yeah, that's about it. Hope you learned something. What the fuck am I saying? All right. That's it. That was Snake and SDL3 C++. We got it done. I thought I was gonna fuck up in some spaces, and I did. I fucked up with the ABBB. I had to like look it up in fucking the Google, and yeah. Hope you enjoy it. I'll see you soon. I might make videos on I don't know what to make a video about next. I guess I could show how you can get community shaders to work in Skyrim. I can do some Daggerfall. Oh, I can also like do like some Might and Magic 7. I really like that game, and I haven't played it for a long time, and I forgot how to play that fucking game, so I'm making like a new playthrough. But yeah. That's about it. That's how you make snakes in plus plus. Hope you enjoy it. Peace.